Hi guys, welcome to the video. My name is Pushpinder Gill, and now we're going to do a video on geometric progression. So this is a basic maths course that we have on Perfect's course. So this would be the web address to explore more about us. This would be the Facebook page where you can give us your valuable like, and any feedback you have, any kind of request you have or anything, you can always email to us as perfectscourse89@gmail.com. Right. So let's go ahead and start with geometric progression. Now, what is geometric progression? Now, let me just give you a simple example, right? I'm going to cut to the chase here. So 2, 4, 8, 16, and so on. So this is something which is a geometric progression where each term is multiplied by a certain number, and that number is same throughout. So what happens? Each term is multiplied by a number, and that number is same throughout. Now let's try to generalize the arithmetic progression here. Now let's suppose that the first term is a, and the second term is a times r, and the third term is a times r into r, that is a times r square, and the fourth term is a times r square into r, which is ar cube, and so on. So what's the first term? A into r to the power 0. What's the second term? A into r to the power 1. What's the third term? A into r to the power 2. So what is going to be the nth term? That is going to be a into r to the power n minus 1. As you can clearly see, this is 3 and this is 2. This is 2 and this is 1. So if this is n, this is going to be equal to n minus 1. So from here I can generalize that the nth term of any geometric progression is going to be a into r to the power n minus 1. So this would be the nth term of any geometric progression. Now let me show you how the sum of the geometric progression is arrived at. Now, this is something that you do not need to know if you are going for a multiple choice question, but let's suppose you want to do it for your K-12 examination or any other examination, then you can actually learn through here. So what is the sum? The sum is equal to a, first term plus the second term plus the third term, and all the way till the last term. And let me say I have r times s. So r times s is going to be ar plus ar square plus ar cube all the way till a into r to the power n. Now if I subtract this from this, as you can clearly see, this and this will get eliminated, this and this will get eliminated, and so on, this will get eliminated, and I'll have s minus r times s to be equal to a minus a into r to the power n. And if I take s common from here, 1 minus r is going to be equal to a common from here, 1 minus r to the power n, and the sum of the terms is going to be equal to a into 1 minus r to the power n divided by 1 minus r. You can also write it to be equal to a into r to the power n minus 1 over r minus 1, right? So that's another way of writing it. Now you can use this if r is greater than 1, and you can use this if r is lesser than 1. Well, again, you know what? It's the same mathematical equation, so you don't need to worry about too much. So this is the sum of the number of terms of when you say of a geometric progression, right? So let me just write down both of the important things over here on the board. That is that the nth term of a geometric progression is equal to a into r to the power n minus 1, and the sum of terms is equal to a into r to the power n minus 1 over r minus 1. So this would be these two expressions here. Now let's talk about geometric mean. What do you mean by geometric mean? Geometric mean is, let's suppose if I want to, there are two terms of geometric progression. Let's suppose 8 and 8 into 4, 32, right? So let's suppose if I want to fit a number from here which is geometrically equal on the left hand side as it is equal on the right hand side, that would be given as under root of 32 into 8, which is going to be equal to under root of 8 into 4 into 8, which is going to be equal to 8 times 2, which is equal to 16. As you can clearly see, 8 2 is 16 and 16 2 is 32. So that means if I say there are two numbers a and b which are in geometric progression, the geometric mean, or they don't need to be geometric progression, because two numbers will always be in some kind of geometric progression, right? So geometric mean of any two numbers would be given as under root of a into b, right? So this is the geometric mean of any two numbers that is equal to the under root of a into b. So that kind of places a number right here in the middle, that is equidistant from here as compared to here geometrically, right? So this would be about the geometric mean. Now let's talk about the sum of terms till infinite number of terms. Let's suppose you have a geometric progression where you have the first term as 1 by 2 and the second term as 1 by 4, third term as 1 by 8, fourth term as 1 by 16, and so on till infinite number of terms. Now the sum, as you know, is equal to a into 1 minus r to the power n divided by 1 minus r. Now if the number of terms are infinite, then the sum is going to be equal to a into 1 minus r to the power infinite divided by 1 minus r. Now this r is a fraction, and a fraction raised to the power infinite is almost equal to 0. If I ask you what is 1 by 2 raised to the power billion? So 1 by 2 raised to the power billion, right? So that is going to be approximately 0, because that is going to be 1 by 2 to the power billion, which is going to be a really, really big number. So understand, when I say fractions, fractions means, from my case, it's from between 0 to 1, which means if this is going to be 0, the sum till infinite terms is going to be equal to a over 1 minus r. So suppose you're understanding what I'm trying to say here. I'm going to write down everything on a piece of slide here. I wanted to see a piece of paper. Okay. So the nth term is equal to a to the power a into r to the power n minus 1. The sum till n terms is equal to a into r to the power n minus 1 over r minus 1. And the sum till infinite terms is equal to a over 1 minus r. And the sum, so not the sum, the geometric mean of any two numbers is under root of a into b. So that's all you need to know, just like that's all you need to know when it comes to geometric progression. So let's go ahead and solve some questions on this, so that we understand what we've just learned here. So general term, geometric mean, that's that. So what is the 16th term of this series? So you can see the series is 2, 4, 8, 16 and so on. So a is equal to 2 and r is equal to 2 as well. So a16 is going to be equal to a into r to the power 15, which is going to be 2 into 2 to the power 15, which is going to be equal to 2 to the power 16. So I suppose you're understanding what I'm trying to say here. Pretty easy question. All you have to do is that a to the power n, a nth term is equal to a into r to the power n minus 1. Let's move on to a little difficult question here. So the question says that what is the value of y such that these three numbers are in geometric progression? So when I say these three numbers are in geometric progression, a is equal to negative 2 by 7. The second term, which is a into r, is equal to y. And the third term, that is a into r square, is equal to negative 7 by 2. So from here, I can easily grasp the value of r. The value of a is negative 2 by 7. ar square is equal to negative 7 by 2, which is equal to a, which is negative 2 by 7, into r square. So that means from here I can clearly say that r square is equal to negative 7 by 2 into negative 7 by 2, that is equal to 49 by 4, which is equal to, if r square is equal to 49 by 4, so if r square is equal to 49 by 4, that means r can be equal to positive 7 by 2 or r can be equal to negative 7 by 2. So if r is positive 7 by 2, then the value of y would be equal to negative 1. And if r is negative 7 by 2, then the value of y is going to be equal to 1. Right? So the value of y is going to be positive or negative of 1. So suppose you're understanding what I'm trying to say here, guys. Let's go ahead to the next question. So let's go ahead and do this question. So this question says that find the sum till n terms of 8, 88, 888 and so on. So I'll have to do a little bit of manipulation in this question here. So I can take 8 common. I'll have 1 plus 11 plus 111 and so on. Now in this case, whenever you get this kind of equation over here, what you can do is you can divide by 9 and you can multiply by 9. So if I multiply by 9 throughout, this is what I'm going to get. and I can say this is equal to 10 minus 1. This is equal to 10 square minus 1. This is equal to 10 to the power 3 minus 1, and so on. So this over here is going to be 8 by 9 times minus 1 is going to come n times, so it's going to be negative of n. So what I can say is 8 by 9 into, so this is going to be a negative n plus 10 plus 10 square all the way. So I'm just taking this to n terms all the way till 10 to the power n. So that is going to be equal to 8 by 9. So the sum of this is going to be a into r raised to the power n minus 1 divided by n minus 1, which is 9, minus n. So that over here is going to be my answer. Now this is the way to do this question if you want to use algebra, you want to get good numbers in your CBSE, ICSE or your K-12 examinations. But when it comes to multiple choice questions, no. This is not the way to do this question, right? Let me show you how to do it. If you have a multiple choice question and you have these your 5 answer options, one of your answer option is going to be equal to what the way it is, that is 8 by 9 into 10 to the power n minus 1 divided by 9 minus n. What you can do is you can plug in n to be equal to 2. If n is equal to 2, then I just have these two terms, and the sum is 8 plus 88. That is equal to 96. That means by plugging in n to be equal to 2, my answer is supposed to be 96. So this is how you do this question when it comes to a multiple choice question. So when n is equal to 2, the sum is supposed to be 96. So that is going to be equal to 8 by 9 into 10 square minus 1 divided by 9 minus 2. So if I try to calculate it, it's going to be 8 by 9 into 10 into 99 divided by 9 minus 2. So this is going to go at 11. So I'm going to get 8 by 9 times 110 minus 2. So that is going to be equal to 8 by 9 times 108. That is going to be equal to 1 and 2, which is going to be equal to 96. Bingo, matching my target, which means this is going to be my answer when it's a multiple choice question. Now understand this thing very, very clearly. The algebra world or your K-12 world is totally different from your multiple choice world. Statutory warning, do not combine these two worlds at all, right? So I suppose you're understanding what I'm trying to say here, that the multiple choice world and the normal world when it comes to math is totally different. So you need to have different strategies for both of these kind of questions, right? So suppose you're understanding this point over here. Moving on to the next question. So let's go ahead and do this question. So the question says that I have to insert two numbers between 3 and 81. Let's suppose the numbers are x and y, such that everything is in geometric progression. So this over here is a, this is ar, this is ar square, this is ar cube. You know, better way of doing that. So a into r, so a is equal to 3, so 3 into r is equal to x, and 3 into r square is equal to y, and 3 into r cube is equal to 81. That means r cube is equal to 27, which means r is equal to plus or minus 3. So I'm going to take the positive 3 part. So that means this number is going to be 3 times 3, 9. This number is going to be 9 times 3, 27. Fine. So we made a little mistake here. This is going to be positive 3 only, because cube of a number, if the cube of a number is positive, then the number has to be positive. So it's going to be 3, 9, 27 and 81, which is my answer here. So suppose you're understanding, the only thing was to label the numbers as ar square and ar cube, right? So I suppose you're understanding this point. Let's move on to the next question. Now this question says that if the arithmetic mean and the geometric mean of a quadratic equation are 8 and 5. Sorry, this is going to be of roots of a quadratic equation, right? So I'm talking about the roots. So if I talk about a quadratic equation's general form is ax square plus bx plus c. Now the arithmetic mean and the geometric mean of the roots of a quadratic equation is 8, 8 and 5. So let's suppose there are two roots of a quadratic equation, alpha and beta. For the sake of simplicity, I'm going to call it p and q. So the arithmetic mean is 8. That means p plus q by 2 is 8. And the geometric mean is 5. That means under root p into q is equal to 5. So I've just gotten two equations. P plus q is equal to 16 and p into q is equal to 25. So as you can see that, so if you've seen the video on quadratic equation, you would know that this b is the sum of the negative of the sum of the roots. This c is the product of the roots, right? So the quadratic equation, this b by a is the product of the roots. So if I say a x square plus bx plus c, then the sum of the roots, the negative of the sum of the roots, or the sum of the roots is going to be negative b by a, and the product of the roots is going to be equal to c by a. So my quadratic equation will turn out to be x square. So I'm just going to do this b by a and this c by a. So this b by a is going to be negative 16 and the c by a is going to be positive 25. So this over here is our quadratic equation. No need to solve the values of p and q. They're going to be turning out to be fractions or something. So I suppose you're understanding this. The only external knowledge we used here is that if there is a quadratic equation, the product of the roots is the value of c by a and the sum of the roots is negative b by a. Right? We're going to do that when we do quadratic equations. So I suppose you're understanding my point over here, guys. So thank you very much for watching this video. And understand this was a basic maths video. I haven't talked about GMAT or GRE or CAT or any other competition exam here. This is just a basic pure math video so that you understand the basics about the math. At the end of the day, you've got to know the math if you want to solve the maths problems for any competitive exam. So this builds up the basics, and then there are strategies for which you can watch different videos. So don't forget to explore more about us on perfect-scores.com. We've got some exciting stuff going on here. Give us your valuable like and give us your valuable feedback at perfectscores89@gmail.com. So this would be about the video, guys. Thank you very much, and I'll see you in the next one.